a very simple, straightforward theorem. I'll state the theorems. Theorem itself, there is no proof and other things. It's a theorem. No proof, no bother about proof. So there are two theorems. One is theorem 1, which states that in an elastic structure, in an elastic frame structure, in our case, plane frame structure, in an elastic structure subjected to a system of loading, subjected to a system of loading, the first partial derivative of strain energy, subject loading, the first partial derivative of the strain energy, that is expressed, that strain energy I derived both in terms of displacement and forces. We have to take only the force relationship which I have written there. That's why I have written force thing only. This Castigliano theorem is only deal with the force only, because I have told subjected to a system of loading, forces only. So you have to take that strain energy expression only with respect to force. Don't bother about displacement expression. Strain energy expression with respect to force only. That strain energy expression with respect to force only you have to take. So you have to take first partial derivative of strain energy with respect to delta J, with respect to delta J, delta J with respect to delta J, or with respect to the displacement with respect to. So this is expression with respect to displacement only, with respect to this first theorem with respect to displacement. So this expression you cannot use it. So you have to use the other two expressions which I have given. So strain energy expression. So with respect to our first partial derivative of strain energy with respect to the displacement delta J at any coordinate or any point at any coordinate J gives that first partial derivative with respect to the displacement at any point or any coordinate gives the force Fj at the coordinate J. And first partial derivative with respect to displacement will give you force. That means this force, the first partial derivative of strain energy with respect to the displacement acting at any point or any coordinate will be equal to the force acting at that coordinate. The J is nothing but the coordinate. Coordinate means the point of reference, the point under consideration. This is your theorem 1. In any elastic structure subjected to a system of loading, the first partial derivative of strain energy expression with respect to displacement, strain energy expression you have to take. First partial derivative of that strain energy with respect to displacement. So with a displacement delta J will give you the force Fj. Next, theorem 2 It is similar to this. In any, again, same thing, in any elastic structure subjected to a system of loading, the first system of loading in equilibrium. That is also another important thing. That structure, when subject to load, should be in equilibrium. That's one of the important things. Which is in equilibrium, then the first partial derivative of strain energy, the expression with respect to forces. With respect to the strain energy, first partial derivative with respect to the force, Fj, acting at any coordinate, gives the displacement, delta J, at the coordinate J. So that's all the change. Here, since strain energy expression we take in terms of displacement, in theorem 2 we take in terms of force. That's all. So same thing in any elastic structure subjected to a system of loading in equilibrium, the first partial derivative, again the same, the first partial derivative of strain energy U expressed in the force form only, expressed in the force form, that is this form, expressed in the force form only, that strain energy expression, with respect to displacement, with respect to force, not displacement, with respect to force Fj at any coordinate J, gives the displacement delta J at that coordinate, delta J at that coordinate. That is that delta U by delta Fj is equal to delta J. This is your Castigliano's second theorem. This is Castigliano's first theorem. So that means, suppose if you take a beam, suppose if you want this point, you have to determine the displacement. So displacement coordinate will be down on account of the load. So in that direction, you find the total strain energy stored by that expression, right? Then at this particular point, you apply a force Pj, right? Find the total strain energy, take the first partial derivative with respect to Pj, you will get the displacement at that point. That is vertical displacement. If you want slope, you apply a moment at that particular point, m, get the total strain energy using the expression for strain energy in terms of force, then take the first partial derivative with respect to that force mj. You will get the slope theta j. That's what that. Right? When you take up the problem, this expression will be very clear. So again, otherwise straight away, this expression you can use it for second theorem. So the Castigliano's second theorem will be used for, so Castigliano's second theorem will be extensively used extensively used for evaluating the displacements, both slope and deflection. Displacement, both slope and deflection in beams, frames, and trusses. So, from this first partial derivative, if you take it, that's the expression for strain energy in trusses. This is the expression for strain energy in case of beams and frames. In terms of forces, in terms of force, you take the first partial derivative. So, that is delta, right? Delta is equal to delta U by delta Fj. That is nothing but that you have to take partial derivative. So if you take first partial derivative, this will be 2Fi into delta Fi by delta F. So that is nothing but sigma of I equals 1 to n. That 2 get cancelled. You have Fi delta Fi by delta U by delta Fi, correct? Delta U by this is nothing but 2F. That is delta U by delta Fi fully. Whatever is there, this divided by dE. And this is for trusses. And for beams and frames, so that delta is given by sigma of integral, here again 2mx by delta mx by delta m. So that is nothing but mx delta mx by delta f j coordinate. That is j coordinate. That you only have to take that derivative dx divided by dx. The two get cancelled. That's all. Straight away you can use that. So these expressions you have to remember, and you can work any problem on trusses, beams, rigid frames, and evaluate slope and deflection using Castigliano's theorem. Then you have one more thing, what is known as dummy load method. For using dummy load method, we should know what is meant by principle of virtual work. That I will just explain it here, so that from from next class onwards, we can straight away go for problems on beams, trusses, and frames. So next, we'll take up what is